Welcome back to another video on the channel. In today's video we're going to be taking a look at question 25 from the Physics External Exam for the QCAA syllabus, 2021's exam I believe, paper 1. Now you would have noticed on the channel I've started splitting up all the questions into individual videos and putting them into their playlists. That way if you only struggle with a certain question you can go watch it on the channel. The full exam is still up on YouTube. However, it also gives you a bit of variety if you only struggle with certain types of questions to go watch those. So if you want to check that out, the link is in the description below. If you guys need a Physics External Exam bundle pack, the link is also in the description below. And then if you have any questions at all during this video, leave something in the comments and I'll try my best to answer it. But let's get straight into it. So question 25, worth 4 marks. The graphs show centrifugal forces required to keep objects with a different mass in uniform circular motion with a constant speed and a constant radius. So here they said a constant speed and a constant radius. So we don't know what the speed is, but we know what the radius is. And we also have our formula for circular motion as well. So I'll be writing that up as well, just because I have mentioned it here. So force of a circular, so centrifugal force is mass times the velocity squared over the radius. Okay. Now that may be important in this thing here. However, let's see what the graph has to tell us here. So here we have force and we have mass. Okay, determine the speeds of the object. So here's a little trick you can do with physics questions. And this doesn't just work with physics, this works with everywhere. If it's a straight line and it's x and that's y. Now x and y can be anything. The gradient is y divided by x. And the area under the curve is y times by x. So here, the gradient of this line here is force divided by mass, because it's the y value divided by quote unquote the x value. So here we know that force divided by mass is actually acceleration here. Now what we've been told in this question here is the radius is 20 centimeters, which we'll convert to SI units as well, but we're after the velocity, which is a constant. Now we know that if we rearrange this formula to get pretty much in terms of force divided by mass, force divided by mass is equivalent to velocity squared over the radius. So we've actually been given this already. We've been given the gradient, which is the ratio of that. And we've also been given this. So we've got this, we've got that, and we can solve for the velocity. All we need to do is find the gradient. Now again, this is a physical paper. You would have to draw this and work out what the gradient is. So I'm going to roughly work it out here. Now, they will allow for an error range with these numbers here because everyone will draw differently. I'm going to use this point here. Now, notice it is in kg, okay? So here it is 0.2, and then here it's in newtons for 6 newtons there, okay? And now I'll use this point here because it's going to be easier to read. So that's 6, 7, 8. 0.08, comma, and then that's 2. So here gradient, I should probably not put m because everyone confused that. Gradient is your rise over your run, okay? So your rise is how much you've changed vertically. So here we can see we've gone from 2 newtons to 6 newtons. So your rise is positive 4. Your run is how much you've moved horizontally in that amount as well. You've gone from 0.08 to 0.2. So that is a difference of 0.12. So that is your gradient. Your gradient is 4 over that. So here we can chuck that in there. We don't even have to simplify it just yet. The radius is 20 centimeters. That in SI units has to be in meters. So to convert it to meters, you have to divide by 100. So 20 over 100 gives you whatever that's going to be. So we have velocity squared over 20 over 100. Now all we have to do is just rearrange to get the velocity by itself. So you would multiply both sides by this. So you have 4 over 0.12 times by, if you're timesing both sides by this here to cancel it out, you're multiplying basically, well, if you go 20 over 100 here and 20 over 100 here, that will cancel out quite well. So we have 20 over 100 equals v squared. So therefore you just have to square root that to get the velocity by itself. So we just have to chuck that into our calculator. So square root 4 over 0.12 times by 20 over 100. So here, this gives us approximately 1.15 v. Now here they want to 1 decimal place, so we would round this up to 1.2 meters per second, which is the velocity. So 1.2. And that's how you answer this question on the exam. If you had any issues with this one here, you need to take a look at circular motion as well. Biggest thing is knowing this graph trick. This will appear everywhere in physics. And if you need a physics external exam bundle pack, the link is in the description below, so go get your downloads. But otherwise, I'll see you guys in the next video.